In this concept, we're going to talk about special right triangles. Now we have two special right triangles having certain angle combinations, okay? So obviously a right angle, right, for it to be considered a right triangle. And then one type has 30 degrees and 60 degrees, right, as the other angles, the acute angles besides the right angle. And then the other triangle is actually an isosceles right triangle, so 90 degrees and then 45, 45. Both of these triangles are special because the values of their trigonometric functions are fairly easy to remember, and the sides have special relationships. Okay, so for example, for the 45, 45, 90 degree triangle, both legs are always equal, right? Because it's an isosceles triangle. So both legs are equal. So if this is 3, you know that this is 3, etc. Okay? And actually the hypotenuse is whatever the value of the legs is multiplied by square root of 2. So if I give you one side in this triangle, or one leg, if I give you the value of one leg in this triangle, you can very easily determine all the others. Or the others too, I mean. So if I tell you that this leg, x equals 3, you know that this is 3, and this is 3 square root of 2. Okay? That's what makes this triangle interesting to consider. For this triangle, so this leg, or the leg opposite to the 30-degree angle, is half the hypotenuse, right? So, or we could say the hypotenuse is twice the leg that's 30 degrees, right? And then the leg that's opposite to the 60-degree angle is the other leg multiplied by square root of 3. Okay, not the hypotenuse. Okay. So if x were 1, you'd have 1, 2, and then square root of 3, or 1 square root of 3. Okay? Here, if x were 1, right, we tried 3, let's try 1. If this x were 1, this would be 1, and this would be 1 square root of 2, or just square root of 2. Oops. 1, 1 square root of 2. Okay? Now, this is a summary of the values for trigonometric functions of these special angles. Okay, 30 degrees, 45 degrees, and 60 degrees. And again, the interest in studying these values, or these specific angles, I should say, is again because the values of their trigonometric functions are fairly simple to remember and to recall and to plug into equations and problems. So that's why they'll show up a lot. Okay? So the sine of 30 degrees is 1/2, very easy to remember. The cosine of 60 degrees is 1/2, right? So again, sine of some angle is equal to the cosine of its complement, or complementary angle, which is 60, right? The sine of 60 degrees is 1/2 square root of 3. The cosine of 30 degrees is 1/2 square root of 3. Okay? So again, complementary angles have the same values of the trig function and its cofunction. 45 degrees, right? Sine of 45 is 1/2 square root of 2. Cosine of 45 is 1/2 square root of 2. So why are these equal? Well, because 45 is the complement of 45, right? Because if you had a 45-degree angle, I mean, you'd need 45 to make it 90. So these two are actually complementary angles. So the sine of 45 is equal to the cosine of 45. Okay? And that's why their values are the same. Same for the other functions. Tan, cotan, secant, cosecant, etc. Okay? Tangent of 30 degrees is 1/3 square root of 3. Cotan of 60 degrees is 1/3 square root of 3. Okay? Tangent of 60 degrees is square root of 3. Cotangent of 30 degrees is square root of 3. Okay? I should have double arrows to show that these are equal. Tangent of 45 is 1. Cotangent of 45 is 1. Okay? Same for secant and cosecant. Okay? The function of one of the angles is equal to the cofunction of its complementary angle. Okay? Let's look at an example. Find the value of x in the triangle below, round to the nearest tenth. So we have a right triangle. This is a right angle, right? And then we have one angle known, 30 degrees. We have one leg known, 4. And we have one side, x, unknown side, x. And of course the hypotenuse, which we don't know. But let's see if we can manage without it. We're not being asked to calculate the hypotenuse. So let's see if we can determine x without requiring the hypotenuse. Okay? So to find x, you must use the tangent function, since it is the function relating the opposite and adjacent side of a right triangle. So again, in this case, we have the 30-degree angle, and we have the adjacent side, and we have the opposite side or leg. We do not have the hypotenuse, so we shouldn't use sine or cosine. We should use tangent, the tangent property, right, which is equal to the opposite divided by the adjacent. So opposite divided by adjacent. Okay, that's the tangent property. So tangent of 30 degrees equals 4 over x, right, so opposite over adjacent. And then in this case, just solve for x. So multiply x by both sides to get it on top and on the other side, and then divide by tangent 30 to separate it from the x and to isolate the x by itself. And simplify, you get x equals 4 divided by tangent 30. We can use the calculator to find the answer, right? Or you could try substituting tangent 30 if you remember its value from your head. Substitute and then round off to the nearest tenth. Or again, the calculator is much simpler in this case, provided you're able to use it. So 4 divided by tangent 30 gives us x equals 6.9 degrees. Okay, yeah, this is no, sorry, x is length. In this case, x is length. So this is units of length, okay? Inches, centimeters, whatever the units are. Okay? And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay. Find acute angle x when 2 cosine x minus square root of 2 equals 0. So this may look intimidating, but it's not. All you need to do is just follow the steps we've been practicing and just solve for x, right? So 2 cosine x minus square root of 2, we could add square root of 2 to both sides. Again, simple algebraic manipulation. We've done this many, many times now. So we get 2 cosine x equals square root of 2, right? I can divide both sides by 2, so I have cosine x equals square root of 2 over 2. And then, like we said, we can take the inverse cosine of both sides. And I'll show you how I want to write it, actually, just to help make sure you understand the concept. So I have cosine x equals square root of 2 over 2. I'm just going to take the inverse cosine of both sides, right? Cosine inverse, cosine inverse. And this is doable by calculator. Of course, you don't have to evaluate anything on the left-hand side. I'm just showing you that the inverse cosine of something is just that something, right? So these do away with each other, right? So the inverse cosine of the cosine of x is just x. So here we have x. But then on the calculator, when you do inverse cosine of square root of 2 over 2, you should get 45 degrees. Right? And why is that? Because the cosine of x is 45 degrees per our table. So the cosine of 45 degrees is square root of 2 over 2, right? So right here, cosine of 45 degrees is 1/2 square root of 2 is the same as square root of 2 over 2. Okay. So the inverse cosine of square root of 2 over 2 is just 45 degrees. And that's how that works. Okay. Very good. So next exercise, find acute angle x when 4 cosine squared x equals 1. Again, may appear a bit intimidating, but it's really not. So standard algebraic manipulation, divide both sides by 4. Again, my goal is to isolate the x. So I'll have cosine squared x equals 1/4. Take the square root, again, because we have a square here and we want to get to the x, we want to separate the x. So cosine x is equal to, so this is really 1/2, but it's not just 1/2, it's plus or minus 1/2. Remember, when taking the square root, you have to take the positive and negative value of the result. Okay? And then if we do inverse cosine of x, now if we do it on the negative 1/2, we're not going to get an acute angle. We're going to get something else, which we'll discuss later. Okay, we're going to get an obtuse angle, a very big angle beyond 90 degrees. But that's not what we want. We're clearly being asked to find an acute angle x when this condition holds true. So in this case, we're just going to take the plus 1/2. Okay, we're going to skip the minus. Okay, so we're going to take the cosine inverse of 1/2, or plus 1/2, or just 1/2. And that will give us 60 degrees. All right. And this is it for this concept. See you in the next video.